You have heard a sound before that stopped you completely, not a loud one, not an explosion or a siren, something quieter than that. A knock from the wrong direction, a voice in an empty hallway, the kind of sound that makes you go still because something in the deep machinery of your brain says, wait. That instinct is ancient. It kept your ancestors alive. When something doesn't fit the pattern, you stop, you listen, you try to understand where it came from before you move on. Science works the same way. And on the night of August 15th, 1977, at the Big Ear Radio Telescope in Delaware, Ohio, an astronomer named Jerry Amon was doing exactly what most astronomers did back then, going through printouts. Long rolls of paper filled with numbers and letters, each one representing the intensity of radio signals picked up from deep space. Most of it was noise, static, the same unremarkable background hum that fills the universe at every frequency. Then he saw it, a vertical column of characters that should not have been there. The signal lasted exactly 72 seconds, the precise window the telescope had to observe any point in the sky as the Earth rotated beneath it. It came from the direction of the constellation Sagittarius. It peaked at 30 times the intensity of the background noise, and it matched, almost perfectly, the profile of what scientists had theorized a signal of extraterrestrial intelligent origin might look like. Jerry Amon circled it in red pen and wrote one word in the margin. Wow. That piece of paper now sits behind glass, and in the nearly 5 decades since that moment, despite hundreds of follow-up observations, and despite the most powerful radio telescopes ever built being pointed at that exact patch of sky, the signal has never repeated. It has never been explained. No natural source has been confirmed. No artificial terrestrial source has been identified. It remains officially an anomaly. But here is the thing that should make you pause. The wow signal is not alone. It is not even unusual in the broader landscape of what science calls anomalies, signals, observations, measurements that arrive cleanly, that cannot be dismissed as equipment error, that refuse to fit inside any framework we currently have. Some are radio signals from deep space, some are patterns in light from distant stars that no known physics fully accounts for. Some are readings from instruments we trust completely, pointing at corners of the universe we thought we understood. They do not arrive dramatically. The universe does not announce itself. These things show up quietly in spreadsheets and printouts and data streams, and scientists circle them in metaphorical red pen and keep watching. And here is what makes this genuinely unsettling. Not exciting, not thrilling, genuinely unsettling. The more powerful our instruments become, the more anomalies we find. Not fewer, more. We are not solving the mystery, we are discovering how large it is. To understand what these anomalies mean, you have to understand what we are actually listening to when we point a telescope at the sky. Every object in the universe, every star, every cloud of gas, every remnant of a dead galaxy radiates energy. That energy travels as electromagnetic waves across the spectrum, from gamma rays at one extreme to radio waves at the other. Radio waves are the most useful for this kind of search because they travel farther without being absorbed. A radio signal generated in a distant part of the galaxy can cross tens of thousands of light years and arrive at Earth still intact, still measurable, still carrying the fingerprint of whatever made it. This is why the wow signal matters structurally. It arrived at 1,420 megahertz, the precise frequency at which neutral hydrogen emits radiation. Hydrogen is the most common element in the universe. Any civilization with knowledge of basic physics would know this frequency. It has been called the universal channel, the one wavelength that any intelligent species would recognize as significant. The signal did not wander. It did not drift across frequencies the way interference from a satellite or an aircraft would. It arrived exactly where it should arrive if something, or someone, had deliberately chosen to transmit at a frequency every civilization in the universe would understand, and then it was gone. We have since pointed every major radio telescope on Earth at that region of sky. The SETI Institute has observed it. The Parkes Observatory in Australia swept it. The upgraded Big Ear successor facilities returned to it repeatedly. In 2016, a team in Florida announced a strong candidate signal from the same direction, which turned out, after further analysis, to originate from a star system with two sun-like stars, a compelling but still unconfirmed lead. Nothing has matched what Eamon found, but the wow signal is, in many ways, the most famous anomaly, which means it is the one most people use to anchor a conversation that is actually much larger. Consider what astronomers call fast radio bursts. First detected in 2007, these are intense pulses of radio energy that last for milliseconds, less time than it takes to blink, and release in that fraction of a second more energy than the sun releases in 3 days. Let that settle for a moment. The sun has been burning for 4.6 billion years. It will burn for roughly another 5 billion. And somewhere in the deep universe, an event lasting less than the time between your heartbeats puts out energy equivalent to 3 days of that star's total output. For years, the source of fast radio bursts was entirely unknown. Some came once and never repeated. Some, rarest, came back, a pulsing at irregular intervals from fixed points in space. The leading scientific consensus today identifies magnetars, the corpses of massive stars spinning at extreme speeds with magnetic fields 1 trillion times stronger than Earth's, as the most likely source for many of them. In 2020, a fast radio burst was detected originating from within our own galaxy, from a known magnetar, which was a major step forward. But here is the detail that does not get resolved by that explanation. Some fast radio bursts show a pattern of repetition that is not random. One source, designated FRB 201211102A and nicknamed the repeater, has been observed to pulse in cycles, active for roughly 90 days, quiet for 67 days, active again. Magnetars do not behave this way. Known natural processes do not produce this kind of clock-like periodicity, and the explanation remains incomplete. The universe is telling us something we do not yet have the language to read. Then there is Tabby's star, formally designated KIC 8462852 and located about 1,400 light-years from Earth. This star became one of the most scrutinized objects in the sky after data from the Kepler Space Telescope showed it dimming in ways that violated every model astronomers had for stellar behavior. Normal dimming from a transiting planet produces a clean, predictable dip in brightness. Tabby's star dimmed by up to 22%, irregularly, asymmetrically, for varying durations. Some dips were shallow, some were deep. None followed the pattern of any natural object passing in front of it. The leading current explanation is a swarm of cometary fragments or dust clouds in irregular orbits. This fits some of the data. It does not fit all of it. Long-term observations have shown the star is also slowly fading overall, dimming by about 3% per century, which cometary dust does not explain. The data is consistent with something orbiting the star. What that something is remains genuinely unresolved. Here is the gut punch fact that stops everything. We have confirmed the existence of over 5,700 exoplanets, worlds orbiting other stars. We have detected the atmospheres of some of them. We have measured the chemical composition of light passing through those atmospheres from hundreds of light years away. Our instruments are now precise enough to detect a single part per billion of a specific molecule in the air of a planet orbiting a distant star. And yet in all of that precision, all of that reach, all of that capability, we have not found a single signal we can confirm as artificial, not one. We have looked at over 1 million stars with modern techniques. The universe contains approximately 2 trillion galaxies. Each galaxy contains hundreds of billions of stars, and from all of that we have so far one circled printout from 1977 that we cannot explain. The silence is not empty. The silence has a shape, and it is the shape of that silence, its size, its consistency, its refusal to break, that is the deepest anomaly of all. Because here is the question that follows you out of the data and into the dark of the room. If the universe is this large, and if the conditions for life are this common, and the science says they are common, we find the building blocks of life in interstellar clouds, in meteorites, like in the atmosphere of a moon of Saturn, then where is everyone? Where is the noise? The physicist Enrico Fermi asked a version of that question at lunch in 1950, and it became one of the most debated problems in all of science. If intelligent life can arise, and it arose here on this ordinary planet, orbiting an ordinary star in an unremarkable arm of a mid-sized galaxy, then the numbers say it should have arisen elsewhere. Many times, millions of times perhaps across billions of years of cosmic history. Some of those civilizations should have had time to spread, to transmit, to make themselves known across the distances, and we should by now be hearing something. We are not. This is called the Fermi paradox, and the anomalies we have been describing, the wow signal, on the repeating fast radio bursts, with their strange periodicities, the unexplained dimming of Tabby's star, do not solve it, but they make it more urgent. They are the places where the silence breaks briefly before closing again. Scientists have proposed many solutions to Fermi's paradox. Perhaps intelligent life is genuinely rare, rarer than the numbers suggest, and we are in fact alone or nearly so. Perhaps civilizations arise and collapse before they develop the capability to transmit across interstellar distances. Perhaps the distances are simply too large, the signals too faint, the window of transmission too brief for any two civilizations to coincide in time and sensitivity. Perhaps we are not listening at the right frequencies or in the right way or for the right things. All of these are scientifically legitimate, but none of them are proven. But there is a perspective that sits beneath all of them, one that the anomalies keep pointing back toward, and it is this. We are very new. The universe is 13.8 billion years old. Modern humans have existed for roughly 300,000 years. We have had radio technology for about 120. We have been capable of detecting signals of the kind we are searching for less than a century. In the full span of cosmic time, we have been listening for the length of a breath. If you compress the age of the universe into a single calendar year, we switched on our first radio telescope on the last day of December, in the final 3 seconds before midnight. The anomalies we have found, the signals we cannot explain, the patterns that break our models, and the strange light from a star 1,400 light-years away, they are not failures of science. They are the exact thing science is supposed to produce. A question held carefully without a false answer filling the space where the real one should be. There is a discipline in that, a kind of courage. It is harder to say we do not know than to reach for a comfortable explanation. The scientific community has for the most part held the line. The wow signal has not been officially attributed to extraterrestrial intelligence. The repeating fast radio bursts have not been declared artificial. Tabby's star has not been labeled a construction project. The anomalies sit in the literature, documented and unresolved, waiting for more data, more time, better instruments. This is how knowledge actually advances. Not by dramatic revelation, but by the slow accumulation of things that don't fit until the picture they form becomes impossible to ignore. What you carry out of this is not an answer. There is no answer to give you. What you carry out is the weight of the question itself, which is a different and more honest thing. You live on a planet orbiting one star among 400 billion in this galaxy alone. That galaxy is one of 2 trillion. The observable universe, the portion we can see from here, stretches 46 billion light-years in every direction. And somewhere in that immensity, on August 15, 1977, something produced a 72-second signal at the one frequency the universe seems to have reserved for the moment when one form of life reaches across the dark toward another. We heard it, we wrote one word, and we are still waiting.